maybe a quick question, if someone has. Yeah.
So thank you for your presentation. Actually, I have a question from the very beginning. You told us that aging cannot be modeled in the centrifuge. So I was wondering why. Because you also said centrifuge is a time machine, so it could be like
a centrifuge you can use for all processes where the stress is the driving force, and so maybe tiring when you model something and stress. Maybe that can be modeled, but if the chemistry of the material has to change due to aging, it cannot be done in a centrifuge.
But aging can also be a reason of mechanical, mechanical movements and like due to creep effects. So that's it's not always chemical. It depends if there's water, for example.
Yeah, that is true, of course. Aging is a difficult word. It can mean a lot.
That's true.
When it's something is chemistry, no, but creep, yes. If you have sufficient long loads on a certain thing that creeps, then it creeps. All material behavior in a centrifuge remains the same. So if it creeps and the load is long enough, then it will creep. But it takes time, of course. But
I don't know if someone has done creep tests in the centrifuge. Is it that can you also take the time as a like?
No, it's not a time machine in this case.
So you need the same time in 1G experiments.
Maybe I need to say something.
Yeah.
It is a time machine because of scaling. Okay, yes. So for example, if you are trying to simulate a problem related to consolidation, okay, we said yesterday, diffusion is scaled by n to the square, right? But the centrifuge is not doing anything magic. The only difference is that the dimension is much smaller.
That's true.
So in reality, instead of having, let's say, 20 meters that need to consolidate, at 1/100, you will have 20 centimeters. So it's purely the size that renders a centrifuge a time machine. So it's not doing
that's a consolidate, but also the permeability scales.
Permeability
also, scales and the size is n times smaller, and the permeability is n times larger, which results in n squared.
Yes,
for consolidation.
Yes, but the material we're using is the same. So actually permeability is not really scale. So if you do a clay layer of 20 centimeters in the centrifuge or outside the centrifuge, submitted to the same stress level, it will consolidate in exactly the same time. The only difference will be the gradient. But the gradient, if you put a big enough pressure on top, perhaps doesn't make such a big difference. So it's the size that is rendering the centrifuge a time machine.
Okay. Yes.
So if it is related to chemistry, I don't think that chemistry will be accelerated. So as Suzanne already said.
And creep behavior, you cannot accelerate the creep. The creep occurs in the normal time.
All right, thank you.
Schedule. Yeah.
Wonderful. So then, for the sake of the cookies, we finish this part of the session now. Please feel free to approach Suzanne for more questions. Thanks again. And we will be back in probably at 11:05, so 15 minutes of break. Thank you.
I'm not sure if this is part of this or not.
Yes, this is really part of this.
Okay.